Okay, so here we have a simple linear regression model. As I told you in the last slides, or we are looking up to this kind of model. Y is equal to b naught plus b1 x plus u. How do we calculate b naught and b1 manually? For the manual calculation, I have some kind of these estimators, OLS estimators. Why these are ordinary least square estimators? Why this is being called OLS estimators? That is a different argument. I'll be uh, taking this issue in the next week. OLS. But here we have estimator. We can calculate B naught by this formula. We can calculate B1 hat by this formula. And we are having one dependent variable. I have taken that dependent variable as Y alphabet. I have taken this independent variable as X alphabet. And according to the requirement of the formula, I need to have sum of x square. So I have the column of x square. I need to have sum of x and y. I have the column of xy. Just I need to put the values, and I'm taking the values from this one. I'm taking example of this MPG and HP. MPG is dependent variable and HP is independent variable. Mileage per gallon. I'm taking these values as dependent variable. This is dependent variable that is copied and taken to this one. This is dependent variable. Okay. And X is independent variable. I am taking again HP, copy, taken to this variable. So now I am having a dependent variable Y, that is mileage per gallon, X, that is HP, the horsepower engine. And according to the formula, I need to get x square and I need to get x into y. So I am having the square of x. So that is a square of x, and I want to get the x into y, or the product of x, y, and that is x multiplied by y. So I have taken the product of this, and ultimately I have got all these values. Okay, and now what we need to have mean of y, we need to have mean of x, we need to have sum of y, we need to have sum of x, we need to have sum of xy and sum of x square because of these formulas. So here I am taking the sum. Take this is column for mean of y, this is cell for mean of y. So what is mean of y? Obviously you know that. How do we take the mean of y? I'm just having a formula, just averages there, and average of the y, that is, so this is the mean of y. Here I'll be taking the mean of x, so I'm again having the average of x. So this is actually the average of x. Sum of y, auto sum, that is sum of y is this one. This is sum of y. This is sum of x, auto sum. This is sum of x, sum of xy, sum of xy, auto sum here. Again, this is sum of xy. So guys, we are having and sum of x square. Where we have gone wrong? Okay, this is sum of xy, x square. So that is auto sum, and this is sum of x square. Okay, so here we have calculated all the required values. Just I have to put this into the formula and get the answer. And how I'm putting in the formula of the b naught? B naught is having sum of x square. So here I am putting the formula sum of x square, I'm just having the values for into the brackets, just to have a very clear calculation. That is sum of x square and sum of y. Sum of x square is this multiplied by sum of y. Sum of y is this. Okay, that is closed. Minus sum of x into sum of xy. Minus sum of x into sum of xy. Sum of x is this, and into sum of xy is this. So that is complete numerator, divided by denominator is n. N is I think it is 81. So far as n is confirmed, it is 81. 82 82 में से ऊपर के दो 81. Yes, it is 81. So 81 should be there. 81. Sorry. Yes, sorry. सारा काम हमने गलत कर दिया. यहाँ पे मुझे n भी लिखना चाहिए था. n is equal to 81. कोई बात नहीं. ओके जी, this one and minus this one again. So इसमें हम कर लेते हैं. Sum of x square is this, ठीक, into sum of y is this, और फिर उसके बाद sum of x is this, multiplied by sum of xy is this, divided by again this one minus this one. और इसके लिए भी ब्रैकेट आपके पास डबल लगानी पड़ेगी, बिकॉज आप एक फार्मूला पूरा लीड करने जा रहे हो. ओके जी, अब है आपके पास n समीशन ऑफ x स्क्वायर, n इज दिस, मल्टीप्लाइड बाय समीशन x स्क्वायर इज दिस, एंड माइनस समीशन x होल स्क्वायर, समीशन x का होल स्क्वायर, सम ऑफ x इनटू सम ऑफ x, that is summation x ka whole square. So this is our B naught, 50.26509. I've just put all these values into the formula and got the value of B naught. And similarly B1, again I'll be doing the same formula for this one, and this is again this one minus this one divided by this one minus this one. Okay ji. So n is this one multiplied by, okay, sorry मैं गलत हो गया हूँ शायद, ये multiply है ना, नहीं सही minus, sorry. अच्छा जी, this one n multiplied by sum of x square, n into xy, n into xy, and minus summation x summation y, minus summation x, this is sum of x, sum of y, divided by n sum of x square multiplied by sum of x square is this, minus sum of x whole square, minus sum of x, sorry, this is sum of x into sum of x. So this is minus 0.1398. So that's how we can calculate easily manually from the data B0 and B1x. And through Excel, I'll be going to the data. Same, values I want to calculate through the software. I'm going to data. I'm having this data analysis. If you do not have the data analysis tab in the data, you can just go to the option again. I'm doing it again slowly. If in the data manual, in the data menu, you are not seeing the data analysis, then go to the file option, and in the option you will be going to add in, then you will go to this Excel add in. Just go and see that all the boxes are checked or not. So if they are not checked, just check it and just make it okay. You will be having this data analysis into this data menu. Okay, so if I want to calculate this regression line through the system, so this is data and data analysis. In the data analysis, you will be having many kind of analysis tools here, but I'm interested in just regression, making it okay. And it is requiring me the input y range. I'm just giving it the y range, that is complete range of y, and this is input x range, that is independent variable. I'm giving it complete range of x input. This is input, and it shows that where this output should be shown. I am just uh, I want this results over here and make it okay. This is our values, and you can see that the same values are coming from here. So intercept b naught you can calculate manually, and the b1, the x variable ratio, you can calculate manually and as well as from the system. Okay guys, now any question you can ask right now. I think I've done correctly, and if you have any problem, I can do it again. But if you don't have the problem, I'll go to other uh, softwares. Please, if you have any question. It means you all are good with it, and I like that. Okay जी, सॉरी मैं इसको खत्म कर रहा हूँ. अच्छा जी. Now here, now we have calculated the b naught and b1. We have calculated the regression line, and that regression line was y is equal to y cap is equal to actually b naught cap plus b1 cap x. That is our regression. That was our regression line. If you see that in the in the last slides, yes, it is there. No, it is not there. Yeah. When we estimate this regression line, the estimated regression line would not be like that. Let me tell you, would not be like that. What estimated regression line would be? That estimated regression line would be like this one. This one. This is our estimated regression line. Y cap is equal to b naught cap plus b1 cap x. That regression line I have calculated. And how I have calculated, I'll be showing you in the next class. But I have calculated this regression line. You see that in this regression line, we do not have any error term factor. Why? Where this error term has gone, where this u has gone. OL estimation, what the estimation we have done right now, that estimation filtered out this error term from this true regression line, because true regression line was disturbed. True regression line was disturbed by the scatteredness of the, or the randomness of the error term. But estimated regression line does not have any kind of disturbance term of the u. So if I plot this kind of a function, if I plot this kind of function, I may have a scattered kind of a random plot. I've shown you earlier the scattered and the random and then the unordered kind of a graph. But when I graph this one, that would give us a very clear regression line. How does it make? Just look at. We have estimated B0 and B1. Now I am just putting this B0 and B1 into my formula. Take. And what is B0? B0 value is 50.26509. 26265 plus minus 0.1398 into x. So that is our actually the fitted regression line. This is our fitted regression line. I'm just fitting it. How I'm doing it? I'm just putting it the values of B0 and B1. So that is B0. This is B0. And this is B1 into x. X is there. I'm just putting the value of x one by one. So that become like this one. And you will see that the rest of the calculation would not be happening because it is giving us 0, because I have put the single cell into, I have to put the single cell into whole row or whole column. So putting single cell into the formula for the whole column, it requires some kind of a lock function, and I'm just locking it down by having sign of this and having sign of this again. I've just locked it down for all the columns right now. Now I can calculate the whole column of estimated values. So these are the estimated values of y. So now I'm taking these three values separately just to show you how does the graph responds. I'm copying it and I'm taking it to this one, and I don't want this calculation. I'm deleting it, and this is our independent factor, and I'm just putting some necessary requirement. I have to go this independent factor on the right side and dependent variables on the left side. Okay, I'm just putting this data again into my graph side, and graph side shows this kind of a scatter diagram. I've told you that the original actual value of y is true regression line. Y is equal to b0 plus b1 x plus u would give you such kind of a randomness in the data, in the graph. But when I plot this fitted line, now I am taking this fitted line into my canvas. I've taken this fitted line to my canvas. That is giving you very straight line function. You can see right now. Can you see it? This original orange points are fitted lines, and fitted line is giving you straight line kind of a function. I can figure it out. Okay, just one, just putting it here, and solid line. Yes, I'm just doing it solid line. This one. Okay. So you can see that our estimated regression line, how does it making, and I can also put a different color. Yes, that's ठीक. Okay. So this is the same kind of regression line I have already shown you in the start without having such kind of a calculation. But right now I have done it again, but through calculation, through estimation of B naught or B1. So this is telling us the same story, that the error terms are lying around the line randomly, scatteredly, and some points are taking this values of y on the positive sides and some kind of values on the negative side. So these error terms actually make this regression line fizzle out. But how can we now calculate error term, where these error terms have gone? uh, as I told you that these error terms have been filtered out. How can it filtered out? uh, and how these two columns are being interpreted? Just listen carefully. These two column interpretation shows that if the x value is 49, then the recorded value of y was 65. But estimation shows that at the value of 49, the estimated value of y should be like that. Should be. That is estimation. Because B naught and B1, what have we have calculated, those B naught and B1 calculated values are telling us that the estimated y, estimated mileage per gallon, if horsepower engine was 49, that has to be what? That has to be 43.41. But from the market, you have taken this mileage per gallon of having this much of horsepower. So this is the difference. Estimation shows that on the value of 49 of horsepower, your mileage per gallon should be like that. That is estimation. But your record is telling us somewhat more gallons performance. So that is actually the positive side of a data. Similarly, there are some positives and there are some negatives. If I go somewhat beyond below to see some good figures. Mhm. Just look at this. Now, take this one or this one. This shows that is estimated mileage per gallon at the rate of 120 horsepower. If your horsepower set to be 120, your mileage per gallon should be 33. But you have recorded from the market that is 25. Now you are recording less with the estimation. So on some side, you are recording less weight or less weightage according to your estimation. And on some other side, you are recording more than your estimation. So there are some kind of a positive external factors, and says on the other side, you may have some kind of a negative external factors that makes these error terms very scattered. And we can easily calculate these error terms by putting this error term E. And how can we calculate it? Just making a simple difference from simple difference of the estimated y from the original y. So that would be some kind of a actual true y minus estimated y. So if you subtract your estimated y from the true y, you can calculate the error term as well. So this is your true y and that is your estimated y. I'm just taking the difference of it. So as I told you that the rate of 49 horsepower engine, your mileage per gallon has to be 43, but that respondent or that observation give you more mileage from the estimated one. How much more? That is 21.98 plus value. And similarly, if I go beyond the this value, you can see this on the value of 66 horsepower, your estimated regression line should be 41, but you're recording less value. How much less value? That is minus 1.43. So you can see that the error terms are somewhere positive and somewhere are negative. And assumption says that the error term, the sum value of error term should be 0. If you remember that we have gone through the assumption that the error term value, the mean of the error term would be 0. So just to see that, I'm taking the mean of it. So mean, I'm taking here as a mean, that is formula average, and average, yes, it is the same sort, and you can see that it is 0. It is 5.26328 with exponent minus 16. It means that from the 16th decimal, this figure starts. If I go to figure out this number, uh, just wait for me. I'm just putting these values into smaller digits. So if I take it to, yes, now you can see the value in numbers, that is 0. The mean of error terms are becoming 0. So guys, this is actually the today's practice of econometrics. I have just taken an example from your book, and just made a model of simple regression. Just took a one variable as dependent variable, another variable as independent variable, and just made a graph of it, and showing you the different kind of a pattern of error terms. Then I estimated the regression line. Estimation of the regression line I've done from the two methods. One is from manual. You can see that's how I calculated the sums of these variables and required values of the formulas. These were the formulas. I've taken all the sums, putting into the formulas, and got the values of b0 and b1. And from that b0 and b1 value, I have calculated the estimated y and the error terms. And I have not only calculated the error, estimated y, but also shown you on the graph of the actual y and the estimated y, and showed you the behavior of this regression line and this error term. A regression line is not being interpreted yet. I'll be doing in the next class how this regression line is being interpreted, how this B0 and B1 should be interpreted, what this B0 is telling us, what this B1 is telling us. That is a different story. But right now, I've just calculated the model. So for assignment, you have the uh, uh, you have to do the same practice. You have to get the get some data. I'll be showing you the data files. I'll be delivering you. I'll be giving you the data files one by one, to one file for each student, and you have to make a graph, like that, and you have to interpret graph. You have to make calculations. You have to estimate the model. You have to estimate the regression lines, and you have to make the graph from the Excel. You're not supposed to make graph from manual and from pencil on the copy. No, you have to calculate all these calculations in the same way as I done into the Excel, and the rest, how these estimation is done through other softwares, I'll be telling you in the next classes or any extra class. So I would like you to have some good visuals of other softwares as well. So guys, this is done for today. If you have any kind of a question, you can ask right now.